Scientific discoveries do not belong to those who make them, they belong to everyone. The universe is full of wonders waiting to be discovered. Jocelyn Bell Burnell. Introduction: Observing nature through the prism of celestial bodies. When I first gazed at the sky through my telescope, a new world filled with wonders and mysteries unfolded before me. That moment became the starting point of my life's journey, and perhaps a new era of human understanding. Like many before me, I could marvel at the beauty of the starry sky, but only through this telescope did I truly grasp what lies beyond the brilliance of the stars. The sky, which we once thought to be eternal and unchanging, revealed itself to be alive and dynamic, filled with movement and patterns that could be observed and studied. Every time I directed the telescope toward the heavens, it was as if I was peeking behind a curtain that concealed the vast cosmos, and that cosmos turned out to be far more complex and incomprehensible than we had ever imagined. In earlier times, when people looked at the stars, they saw in them immutable symbols of eternity. To ancient philosophers, the stars were steadfast points of light, fixed upon celestial spheres that revolved around the earth. These spheres were believed to be perfect and beyond change. The stars we see today were the same stars our ancestors saw, and those before them. This created the illusion that the heavens were a frozen backdrop against which the events of human life unfolded. For ancient astronomers such as Pythagoras and Plato, the heavens were the embodiment of order and harmony, where every star and planet occupied its unchanging place. This idea of the immobility and perfection of the heavens was so deeply rooted in human consciousness that any attempt to challenge it was met with resistance. How could something so beautiful and divine be subject to change? Yet my observations began to unravel this ideal. The sky was not simply a beautiful picture, but a living, changing system made up of objects that moved, collided, and transformed, all governed by the same laws of nature that apply here on Earth. As a pioneer, I felt like a traveler taking his first steps on unknown land, discovering a world full of life, movement, and interconnections. Each new glance through the telescope revealed more and more details: planets that were not just glowing points but real bodies with moons and satellites, comets racing along their orbits, stars that were not static but followed their own laws of motion. This new cosmos appeared to me as alive, breathing, and incredibly dynamic. The solar system became the central focus of my observations and reflections. It was the nearest part of the universe where I could study the laws governing the movement of celestial bodies. Yet even this small section of the cosmos was full of mysteries. Why do planets revolve around the sun? What forces govern their movements? These questions led me deeper and deeper, from observation to calculation, from speculation to discovery. I began to understand that unraveling the structure of the solar system could provide a key to understanding the entire universe. If the same laws that govern the movement of planets also apply to Earth, then they must be universal. The laws of nature are the same for all objects, whether they are on our planet or beyond it. This idea became my guiding thread in my research. If we could understand how planets move around the sun, we could also understand how stars move within galaxies, how planetary systems form, and how celestial bodies interact throughout the cosmos. However, the path to knowledge always begins with doubt. For centuries, humanity lived in the conviction that the Earth was the center of the universe, a fixed point around which everything else revolved. This idea was so deeply ingrained that any attempt to question it was met with condemnation and disbelief. To doubt this meant challenging not only philosophical views but the very nature of things. Yet I asked myself, what if the world is structured differently? What if the Earth itself moves? What if the stars and planets are subject to laws that have yet to be discovered? When I first began observing the heavens through my telescope, I witnessed astonishing things. I saw how planets slowly moved across the night sky, how stars flickered in the distance, and all of this made me ponder whether the ancient views on the universe's structure were wrong. The heavens were not the perfect, immutable realm described by philosophers. It was a world full of movement and life, a world governed by its own laws, far removed from what we had considered unchangeable. I realized that the Earth was just one of many planets, moving along its orbit around the Sun. This discovery changed everything. Our planet was part of a much more complex and dynamic system than we had ever imagined. But how could I prove this to the world? How could I convince people that their views on the cosmos were mistaken? I understood that although my observations were clear evidence to me, they might not convince everyone. Thus, I dedicated my life to continuing my observations of the heavens, studying their movements, and seeking patterns that could be explained mathematically. Gradually, I came to understand that the laws of nature governing the movement of planets were the same principles that govern the movement of objects on Earth. I concluded that the movement of celestial bodies could be described by mathematical formulas, and this changed everything. Planets did not just wander across the sky, they followed precise orbits that could be measured and predicted. I realized that the Sun, positioned at the center of these orbits, played a key role in the movement of all planets. This became the foundation of all my subsequent research. With each new observation, I grew more convinced that the Earth was just one of many planets and that it moved along its orbit around the Sun, much like the satellites I observed orbiting Jupiter. My telescope allowed me to see what the naked eye could not. I observed the movements of Jupiter's moons, the phases of Venus, the spots on the Sun. All these observations strengthened my belief that the universe was far more complex than previously thought. I understood that the Earth was not the center of the universe and that our place in the cosmos was not as unique as it once seemed. Yet, knowledge always faces resistance. When I presented my discoveries to the world, many rejected them. My observations were seen as a challenge to the established views, and this caused an uproar. But I knew that the truth always comes to light and that time would prove the importance of my discoveries. Doubt in the truth is only the first step toward accepting it. I understood that sooner or later my observations would be recognized, and people would begin to see the universe as it truly is, alive, dynamic, full of movement and patterns. My telescope became my window to the world of the stars. With it, I saw how planets moved, how they followed their paths, how they adhered to the laws I was beginning to comprehend. The Sun, once thought to be stationary and unchanging, revealed itself as the center of the entire solar system. I realized that its role in the movement of the planets was undeniable. I watched the moons orbit Jupiter, saw Venus pass through its phases, and observed the Moon in its perpetual journey around Earth. All of this became proof that the universe was in motion, alive, breathing, and that mankind could understand it if we opened our minds to doubt and knowledge. Thus, the solar system appeared to me not just as a collection of celestial bodies but as a unified whole, governed by the laws of nature. I understood that the laws of motion I observed applied to the entire universe and that studying these laws would give us the key to understanding the cosmos. The Sun, the planets, the moons, all of them became living proof that the universe was not static but adhered to strict, yet majestic, laws that humanity could grasp if we were persistent enough in our pursuit of knowledge. The Sun, on the heart of the system. At the very center of our cosmic existence lies the Sun, a majestic and powerful source of light, heat, and life. It is not just a celestial body illuminating our path, but the very heart of the solar system, making possible the existence and motion of planets and their life. With its radiant glow reaching every corner of our system, the Sun not only provides light but also orchestrates the order, harmony, and life that extend across vast distances, almost beyond our imagination. Each morning, the Sun rises on the horizon, gifting light and warmth, awakening nature, driving climatic processes, and setting the rhythm of the day. But what do we truly see in it? Only a faint echo of its grandiose power, a force that we are only beginning to comprehend. The sunlight that touches Earth's surface doesn't just maintain a comfortable temperature for us, it is the energy without which life on our planet would be impossible. Everything we know, from plants to animals, from rivers to oceans, thrives on this energy. Sunlight is not just a stream of photons, it is the foundation of existence for our entire planetary system, stretching from Mercury, the closest planet to the Sun, to the farthest hidden objects in the cosmic abyss. The Sun is far from the static, glowing orb that ancient peoples envisioned. It is a colossal sphere of burning gases, where forces beyond our comprehension interact at its core, releasing energy that erupts outward. Its core, where nuclear fusion takes place, is the engine of the Sun. In the heart of this giant star, atoms of hydrogen fuse to form helium, releasing tremendous amounts of energy. This process is the source of the light and heat that travel across vast distances to reach us. But the Sun is not just a source of energy. It is the gravitational anchor of the entire system. Its immense gravitational force is so powerful that it controls the motion of all the planets, holding them in their orbits. The Sun's gravity shapes the trajectories of these planets, speeding them up or slowing them down depending on their distance from the Sun. I began to understand this as I observed the planet's movements through my telescope. The closer a planet is to the Sun, the faster it moves along its orbit, the farther it is, the slower it travels. This realization became key to understanding the motion of all celestial bodies, from Mercury to Jupiter and Saturn. The order and harmony concealed behind the apparent chaos of the heavens became an astounding revelation. While the Sun appears to us as a stationary center of our system, it too is in motion. It moves with the entire solar system around the center of our galaxy, the Milky Way, involved in the eternal dance of the cosmos. Yet for us, inhabitants of Earth, the Sun remains the heart of our system, around which everything revolves and submits to its immense power. Without its gravitational pull, the planets would scatter in all directions, abandoning their orbits, but the Sun's force holds them in place, creating a magnificent balance and harmony. What makes the Sun so unique? Its massive size, accounting for 99.86% of the entire solar system's mass, provides an immense gravitational pull that governs everything within its reach. The Sun not only holds the planets but also comets, asteroids, and countless other objects under its gravitational dominion. This delicate balance of gravitational interactions creates the harmonious motion that we observe in the orbits of the planets. And although the Sun seems stationary to us, it too moves through the galaxy, traveling through the vast reaches of space. Each planet in our system feels the influence of the Sun differently. Mercury, the closest planet, races along its orbit in just 88 days, while Jupiter takes 12 Earth years, and Saturn nearly 30 years, to complete its journey around the Sun. This astonishing diversity of orbital periods further confirmed to me that the Sun is not only the center of the solar system but also its great ruler, controlling everything with its laws. But what lies within the Sun's core? What processes create such unimaginable power? We know little about the depths of the Sun. Nuclear fusion, the fusion of hydrogen into helium, releases vast amounts of energy, which then escapes as light and heat. This process has continued for millions of years, creating the stability that sustains all life on the planets. But what happens when these reactions change? What effect might this have on the planets and moons orbiting the Sun? My observations of sunspots were a significant step in understanding that the Sun is not a static object. I noticed that the spots appeared and disappeared, their shapes and sizes fluctuating, which indicated that complex processes were happening within the Sun. These sunspots are the result of disturbances in the Sun's magnetic field, creating localized areas of lower temperature. But why do they form? What cycles govern their appearance? And how do they influence the solar system as a whole? Sunspots are yet another mystery that humanity has yet to solve. But I am certain that they play an essential role in the life of the Sun and the entire solar system. Perhaps they are tied to changes in solar activity, which in turn may affect the climate on Earth and other planets. These processes, which we do not yet fully understand, may have a profound influence on all life in our system. The Sun's light and energy travel across distances that are hard to comprehend. The sunlight we see on Earth travels 150 million kilometers in just 8 minutes. But what happens to this light when it reaches the outermost planets of our system? What role does it play on distant worlds like Neptune or Pluto? Can solar energy sustain unknown forms of life on other planets or their moons? We do not yet know the answers to these questions, but I am confident that the future of space exploration will reveal even more of these mysteries. The Sun is the heart of our system, and its light reaches every corner of space. It gives life to the planets and their moons, maintains the atmosphere of Earth, and influences ocean currents, weather patterns, and climate. Its light brings everything on our planet to life, providing the energy and power for all living things to grow and flourish. But the Sun is not just the source of life, it is also a symbol of harmony and order in the universe. Everything we see, everything we observe, is tied to its power and influence. I continue my observations, and with each passing day, I become more convinced that the Sun is the key to understanding the entire universe. Its light illuminates our path to knowledge, and I have no doubt that with each new discovery, we will come closer to unlocking the secrets of the cosmos. The Sun is not just a shining orb in the sky, it is our heart, our guide through the vastness of space. Its light continues to lead us on the great journey of discovery, and each ray gives us hope that one day we will comprehend the full truth about the cosmos and our place within it. Mercury, the first traveler around the Sun. Mercury, the first planet from the Sun, is one of the closest objects to our star within the solar system. Astronomically, it is like a swift traveler racing along its orbit with such speed that observing it presents a challenge even for the most powerful instruments. Closest to the light and heat of the Sun, Mercury is the living embodiment of speed and motion, seemingly gliding through the heavens with incredible swiftness. This celestial traveler completes its orbit around the Sun in a remarkably short period, just 88 Earth days. When I direct my instruments toward Mercury, I observe a world caught in the relentless grip of solar radiation. Its surface, scorched and cratered, bears the scars of collisions and cataclysms that shaped this unforgiving world billions of years ago. Stripped of any atmosphere, this small world is constantly exposed to the unyielding forces of solar radiation, with its surface enduring extreme temperature fluctuations day and night. On the daylight side, Mercury blazes under the searing heat, while its night side plunges into frigid darkness. Yet Mercury is not merely the closest planet to the Sun, it is the first traveler among the planets, a living witness to the Sun's immense power. Its orbit is so close to the Sun that it experiences the intense effects of solar wind and radiation. Mercury seems to be directly shaped by the Sun's influence, with its movement, its surface, and even its very essence affected by the mighty forces of the Sun. The gravitational pull of the Sun holds Mercury so close that the planet moves at the greatest speed of all the planets in the solar system. As the innermost planet, it races through space with a velocity that far surpasses its fellow celestial bodies. Because of its proximity to the Sun, Mercury almost always eludes the observer's eye. Like a hidden traveler of the night, it appears only for brief moments in the early morning or late evening, revealing itself in the fleeting glow of dawn or dusk. In these rare moments, the planet's elusive nature becomes evident, but as soon as the Sun rises higher in the sky or dips below the horizon, Mercury vanishes once again into the blinding brilliance of the Sun. Each time I attempt to observe this swift planet, it feels as though I am in a race against time, trying to catch a glimpse of its details before it disappears into the Sun's glare. Mercury's rapid movement and its closeness to the Sun make it a challenging object even for experienced astronomers. For centuries, people believed that celestial bodies like Mercury and Venus merely followed the Sun in its apparent movement across the sky. However, my observations dispelled this myth. Mercury follows its own orbit, adhering to the laws of motion I uncovered, and its trajectory is not random but a manifestation of a higher mathematical harmony. Mercury is the perfect object for studying the Sun's gravitational influence on planets. Its proximity to the Sun makes it a vivid example of how solar gravity governs the movements of celestial bodies. Its orbit illustrates the power and majesty of the natural laws that I have begun to understand through my observations. The closer Mercury is to the Sun, the faster it moves, and vice versa. This phenomenon is a demonstration of one of the fundamental principles I discovered during my studies. This scorched and sun-baked world is also a symbol of the vulnerability of planets before the might of the Sun. Mercury is devoid of an atmosphere that could shield it from the relentless solar radiation. Without such protection, its surface is riddled with deep craters, silent witnesses to countless collisions with meteors. And yet, despite all these challenges, Mercury continues its relentless journey around the Sun, adhering to the immutable laws of nature. Its orbit is elliptical, which means that in some parts of its path, Mercury is closer to the Sun, while in others, it is farther away. This change in distance affects its speed. The closer the planet is to the Sun, the faster it moves, and the farther it is, the slower it travels. This principle, which I discovered, explains why planets move at different speeds and how the Sun governs their orbits. Mercury, being the closest to the Sun, demonstrates this phenomenon most vividly. Mercury is also a planet of extreme contrasts. Its day lasts as long as its year, which means that one side of the planet is exposed to deadly heat for many days, while the other side remains in freezing darkness. The temperature fluctuations on Mercury are staggering. The daytime side can reach temperatures as high as 430 degrees Celsius (800 degrees Fahrenheit), while on the nighttime side, the temperature can drop to -180 degrees Celsius (-290 degrees Fahrenheit). This stark contrast between day and night demonstrates just how extreme the conditions are on planets that are so close to the Sun. It is interesting to note that despite its proximity to the Sun, Mercury remains one of the least studied planets. Its closeness to the Sun makes it extremely difficult to observe, and even modern instruments often struggle to capture it in as much detail as planets like Mars or Venus. But I am confident that further research will provide us with more knowledge about the nature of this enigmatic planet. Perhaps one day humanity will be able to send its machines to Mercury to explore its surface and unlock its secrets. Yet for now, Mercury remains a mystery to us. It is the first traveler, the closest to the Sun, the fastest and most elusive of all the planets. It continues its journey, following the inexorable laws of nature, and its existence serves as proof that the solar system is governed by strict and unchanging laws of harmony. Mercury is a planet that demonstrates the Sun's power and its control over all the celestial bodies. When I reflect on Mercury, I imagine its harsh landscape, forever exposed to the relentless rays of the Sun, with no shadow or protection. This world, like a scorched desert, continues its journey around the Sun, following its unique path. And while it may often elude our eyes, its role in the solar system cannot be overstated. Mercury is the first traveler, showing us how the universe operates and how the Sun governs all the planets. Its orbit around the Sun is a symbol of both precedence and vulnerability before the power of solar energy. And although it is difficult to observe, Mercury continues to inspire me to make new discoveries and reflect on the nature of the cosmos. Venus, the shrouded goddess of the skies. Venus, the second planet from the Sun, shines brighter than any star in the sky. Its radiance is so intense that many ancient cultures revered it as a heavenly goddess, unaware that it was simply another planet following the same laws of motion as Earth. However, Venus is shrouded from our view by a thick layer of clouds. These clouds obscure its surface, leaving room for speculation and wonder. It would be a great joy to discover what lies beneath these clouds. Could there be continents and oceans, similar to those on Earth? If Venus's atmosphere is so dense, perhaps there are rains and winds, just as we have here. Future observations may shed light on these mysteries, as no matter how different the worlds may be, they are all governed by the same universal laws. Venus, with its blinding brilliance, is often mistaken for a star by the untrained eye. Yet, unlike the distant points of light we call stars, Venus is a neighboring world, one that holds many secrets behind its dense atmosphere. This thick layer of clouds, composed of sulfuric acid, creates a nearly impenetrable barrier, preventing direct observation of the planet's surface. Despite this, Venus beckons with its dazzling light, leaving astronomers and philosophers alike to wonder about the true nature of this veiled planet. Through my telescope, I could only see the light reflected from these clouds, but I imagined what might lie beneath them. Venus, nearly the same size as Earth, could once have been a twin to our world. Perhaps, in its distant past, it too had oceans, rivers, and a thriving environment. Yet today, it is a world of extremes, where surface temperatures are hot enough to melt lead, and the atmospheric pressure is so high that it could crush a human standing on its surface. Despite these harsh conditions, Venus follows the same laws of motion as Earth. Its orbit around the Sun is nearly circular, and like Earth, it experiences phases as it moves between the Sun and our planet. These phases, much like those of the Moon, were one of the key observations that led me to understand that Venus orbits the Sun, not Earth, challenging the long-held belief in a geocentric universe. The dense atmosphere of Venus creates a powerful greenhouse effect, trapping heat and raising the planet's surface temperature to over 450 degrees Celsius (850 degrees Fahrenheit). This is an environment far too hostile for any life forms that we know of, but it serves as a stark reminder of the delicate balance of forces that make Earth habitable. Venus serves as a stark contrast to Earth in its extreme conditions, yet the similarities in their size and proximity to the Sun compel us to wonder what might have once been. It is possible that Venus was once a more hospitable world, with a climate capable of sustaining oceans and perhaps even life. However, its dense atmosphere, composed primarily of carbon dioxide and clouds of sulfuric acid, created a runaway greenhouse effect, trapping so much heat that the surface transformed into a scorching, uninhabitable wasteland. This is a powerful reminder of how fragile and interdependent the conditions that sustain life can be. The atmosphere on Venus is so thick that it exerts a crushing pressure, about 92 times greater than Earth's at sea level. To walk on the surface of Venus would be akin to descending to the depths of Earth's oceans, where the pressure would be intolerable for humans and most known life forms. The air is filled with toxic gases, and the planet is perpetually shrouded in clouds so dense that sunlight barely penetrates to the surface. Venus, although bathed in the same sunlight as Earth, has become a furnace, a warning of what happens when natural balances are disrupted. As I gazed at Venus through my telescope, I often wondered what forces could have transformed such a potentially Earth-like world into this fiery inferno. Could it have been a cataclysmic volcanic eruption, releasing gases that choked the atmosphere? Or was it a gradual process, where small changes over millions of years eventually turned Venus into the scorching planet it is today? The mystery of Venus captivates me as it stands as a cautionary tale about the delicate balance that governs planetary climates. While Venus's thick cloud cover obscures its surface, modern observations have revealed some of the planet's hidden features. Beneath the clouds lies a landscape dominated by vast plains of volcanic rock, towering mountains, and deep valleys. There is evidence that Venus is still geologically active, with its surface reshaped by volcanic eruptions and tectonic forces. This geological dynamism mirrors some aspects of Earth, yet everything on Venus is intensified by the oppressive heat and pressure. Its mountains soar higher, and its volcanic activity may be far more intense than what we see on Earth. One of the most remarkable aspects of Venus is its unusual rotation. While most planets, including Earth, rotate on their axes from west to east, Venus spins in the opposite direction, from east to west. This retrograde rotation is a mystery, and scientists have long speculated about what might have caused it. Could it have been the result of a massive collision with another celestial body early in Venus's history, or perhaps some gradual tidal forces exerted by the Sun? Whatever the cause, Venus's slow rotation means that a day on Venus lasts longer than its year. One full rotation takes 243 Earth days, while a full orbit around the Sun takes only 225 Earth days. This strange fact adds yet another layer of intrigue to this already enigmatic planet. The slow rotation of Venus, combined with its dense atmosphere, creates extreme weather patterns. The winds in the upper atmosphere of Venus can reach speeds of up to 360 km per hour, 224 miles per hour, far faster than any wind on Earth. These winds circle the planet, creating massive vortices at the poles and driving the thick clouds around in a never-ending storm. However, on the surface of Venus, the winds are much gentler due to the high density of the atmosphere. Yet the planet remains locked in its furnace-like conditions, where temperatures remain constant across the entire surface, both day and night, thanks to the heat-trapping power of the atmosphere. Despite its inhospitable environment, Venus continues to inspire dreams of exploration. While landing on Venus presents immense challenges due to the planet's hostile conditions, our curiosity about this veiled world persists. What might future missions reveal about Venus's past? Could we one day find signs that it once harbored water, or even microbial life, in its distant history? Venus, with its many layers of mystery, beckons us to push the boundaries of our knowledge and technology in search of answers. The phases of Venus, much like those of our Moon, provided one of the key observations that led me to question the traditional geocentric model of the universe. As Venus moves between Earth and the Sun, it goes through a cycle of phases, from a bright crescent to a nearly full disk, depending on its position relative to us. This was definitive proof that Venus, like Earth, orbits the Sun, and not the Earth as was long believed. This revelation played a pivotal role in reshaping our understanding of the cosmos, reinforcing the idea that our planet is not the center of all celestial motion. When I reflect on Venus, I cannot help but marvel at how different yet connected our neighboring worlds can be. Venus, so similar to Earth in size and composition, evolved into a completely different world, shaped by the forces of nature in ways we are only beginning to understand. Its dense atmosphere, scorching surface, and mysterious clouds stand in stark contrast to the life-supporting environment of Earth. And yet, Venus reminds us that the same universal laws of physics apply to every planet, no matter how diverse their conditions may be. Venus, the brightest object in our night sky after the Moon, has captivated humanity for millennia. Ancient cultures worshipped it as the goddess of love and beauty, not knowing that behind its radiance lay a world of extremes. Today, Venus serves as both a scientific enigma and a reminder of the delicate balance that governs planetary systems. It teaches us that planets, even those that seem similar, can evolve in drastically different ways depending on the forces acting upon them. Venus is a planetary paradox, both beautiful and deadly, revealing to us the complexities of the universe we are only beginning to explore. Earth, our home among the stars. Earth is unique not because it sits at the center of the universe, as our ancestors once believed, but because it moves among the stars, orbiting the Sun along with other planets. For years, I sought to prove this simple yet profound truth through observation. By watching the movement of planets and stars, I came to the conclusion that Earth does not sit motionless at the center of the cosmos but travels along its orbit, making an annual journey around the Sun. This journey, which we call a year, gives us the changing seasons. The tilt of Earth's axis causes the alternation of winter and summer, autumn and spring. Our planet rotates on its axis, giving us day and night, while its orbit around the Sun allows us to measure time relative to the positions of celestial bodies. Earth, our home, is the only planet we know of that supports life. Its atmosphere, oceans, and land provide everything needed for millions of species, including us, to survive and thrive. But as I studied the stars and planets, I realized that Earth is just one small part of the greater universe. It is not the center of all things but a traveler, moving through space along with other planets in a system governed by the same universal laws. Earth's motion around the Sun became clear through the patterns of the stars and planets in the sky. As our planet moves, the stars shift in relation to us, creating what we call the changing of the seasons. I observed that the Sun's position in the sky changes over the course of the year, rising higher during summer and lower during winter. This movement is a direct result of Earth's orbit around the Sun, proving that we are not stationary. In ancient times, people believed that the stars were fixed in place, that they represented an unchanging backdrop to the events of human life. But my observations showed that the heavens were in constant motion. Earth itself moves, following a path determined by the gravitational pull of the Sun. And just as Earth orbits the Sun, so too do the other planets, each following its own trajectory. Our planet's rotation and orbit are part of the grand cosmic dance that governs all celestial bodies. The force of gravity, which keeps Earth in its orbit, is the same force that governs the movement of every planet, star, and galaxy. By understanding how Earth moves, we can understand how the universe operates on a grander scale. But even as I gazed at the heavens and pondered the mysteries of the cosmos, I never lost sight of the importance of our own world. Earth is not just another planet, it is our home, the only place where life has taken hold. Its perfect distance from the sun, its protective atmosphere, and its abundant water have created a unique environment where life can flourish. And yet, as I studied Earth's place in the cosmos, I came to understand that our world is fragile. Earth, while robust in many ways, is fragile in its balance. Its atmosphere, which provides the air we breathe and shields us from harmful radiation, is but a thin veil that separates life from the cold vacuum of space. The delicate interplay between the sun's energy and Earth's atmosphere creates the climate patterns that sustain ecosystems across the globe. The oceans, which cover the majority of our planet's surface, are not just vast bodies of water, they are the regulators of climate, the cradle of life, and the bearers of history, containing secrets of the planet's past and perhaps clues to its future. As I studied the heavens, I realized that Earth, though small in comparison to the vastness of the universe, holds within it a unique and intricate complexity that sets it apart from the other planets. Here, on Earth, life thrives because of the perfect balance of conditions. The distance from the sun is just right, not too close to cause unbearable heat, as on Mercury, and not too far to freeze, as on the outer planets. Our planet is just the right size, with enough gravity to hold on to an atmosphere but not so much that it would crush living beings under its weight. Yet even as I marveled at the balance of forces that sustain life on Earth, I could not help but wonder how long this balance would last. I saw evidence in the movements of other planets that worlds can change dramatically over time. Mars, which today is a barren desert, shows signs that it once had flowing water and a thicker atmosphere. Venus, which now endures unbearable heat, may have once had conditions similar to Earth's before its climate spiraled into catastrophe. These neighboring planets serve as reminders that planetary environments are not permanent. Earth, too, could change if its delicate balance were disrupted. The Earth's movement around the sun provides not only the changing of seasons but also the flow of time itself. Each rotation of the planet brings us day and night, while its orbit marks the passage of years. This rhythm of time has governed life on Earth since its beginning, and life, in turn, has adapted to it. Plants grow in sync with the sun's light, animals migrate with the changing seasons, and human civilizations have long relied on the cycle of days and years to measure their existence. But Earth's orbit, as stable as it seems, is not immune to outside forces. The gravitational pull of other planets and even distant stars subtly influences the planet's motion over long periods. The tilt of Earth's axis, which gives us our seasons, shifts slightly over millennia, altering the climate in ways we are only beginning to understand. These slow, imperceptible changes remind us that Earth, like all planets, is part of a dynamic, ever-changing cosmos. While Earth moves through space, it also interacts with other bodies in the solar system. The Moon, Earth's constant companion, exerts a powerful gravitational pull on our planet, causing the tides that shape coastlines and affect marine life. Without the Moon's stabilizing influence, Earth's axial tilt could fluctuate more wildly, leading to extreme shifts in climate that might make life as we know it impossible. The relationship between Earth and the Moon is a testament to the interconnectedness of all celestial bodies, and it serves as a reminder that even our planet's stability depends on forces far beyond its surface. As I ponder Earth's place in the universe, I cannot help but reflect on the wonder of its atmosphere. This thin layer of gases, primarily nitrogen and oxygen, is a fragile barrier that protects us from the harsh conditions of space. It filters harmful solar radiation, regulates temperature, and provides the air we breathe. The presence of oxygen, which sustains all animal life, is a direct result of billions of years of photosynthesis by plants and microorganisms. The atmosphere, then, is not just a passive shield, it is a dynamic system, constantly interacting with the living organisms on the planet's surface. Earth's atmosphere also reveals itself in the majestic phenomena that occur within it, the auroras, caused by solar winds interacting with the planet's magnetic field, the clouds, which carry water from oceans to land, sustaining ecosystems and human life, and the storms, both gentle and fierce, that remind us of the planet's dynamic nature. Each of these natural wonders is a testament to the complex processes that make Earth unique, a planet teeming with life in a universe that often seems indifferent to it. Despite its beauty and balance, Earth's environment is vulnerable to change. As I observed the planets, I understood that even small shifts in a planet's atmosphere or orbit could have profound effects. I saw that Venus, once possibly temperate, had been transformed into an inferno due to its thick atmosphere trapping heat. I imagined that Mars, once home to rivers and lakes, had lost much of its atmosphere, leaving it dry and barren. These planetary changes were stark reminders that Earth, too, could face similar fates if its climate were to shift dramatically. I realized that our planet's future, like that of Venus or Mars, is not guaranteed. Earth is constantly changing, and the forces that sustain life here are fragile. Human activity, though a relatively new factor in the planet's long history, could have significant impacts on its climate, atmosphere, and ecosystems. The very elements that make Earth a haven for life, its atmosphere, its oceans, its forests, are susceptible to disruption. As I studied the heavens, I became ever more aware of the preciousness of Earth. While other planets may harbor the potential for life, none that we have observed are as perfectly suited to support such a diverse range of organisms. Earth is not just another planet, it is our only home, a unique world where life has flourished for billions of years. And yet, as we learn more about the universe, we must also recognize the responsibility we have to protect and preserve this fragile world. Earth's journey through space is both a metaphor and a reality. It is a reminder that we are all travelers on this planet, moving together through the vastness of the cosmos. Our existence is intertwined with the forces of the universe, from the sun's life-giving light to the gravitational pull of distant stars. We are part of a cosmic system, governed by laws that we are only beginning to understand. As I look to the future, I imagine a time when humanity will come to fully appreciate Earth's place in the cosmos. Perhaps one day, we will venture beyond our solar system, exploring distant planets and stars. But even as we reach for the stars, we must remember the importance of caring for our home planet. Earth is the only world we know of that supports life, and its unique conditions make it a sanctuary in the vastness of space. In our quest to understand the universe, we must never lose sight of the extraordinary gift we have been given in the form of our planet. Earth is not just a dot in the cosmos, it is a world full of life, beauty, and complexity. It is our responsibility to safeguard it for future generations, to ensure that life can continue to flourish here even as we explore the farthest reaches of space. Mars, the red planet, and our dreams of life beyond Earth. Mars, the fourth planet from the Sun, has long captivated human imagination with its reddish hue and mysterious landscapes. Its ruddy color evokes images of war and desolation, and many ancient cultures named it after their gods of war. But beneath its red dust lies a world that once might have been very different. Could Mars have harbored life in its ancient past? Could its dry riverbeds and towering volcanoes hold clues to a time when the planet was wetter, warmer, and more hospitable to life? Mars is a world that simultaneously feels familiar and alien. It has mountains, valleys, and plains, much like Earth, but its atmosphere is thin, its surface barren, and its temperature frigid. Yet, the possibility that Mars once had liquid water, the key ingredient for life as we know it, sparks the imagination. The question of whether life ever existed on Mars is one of the greatest mysteries of our time, and the search for answers has driven numerous missions to the planet. My heart is filled with the desire to understand the secrets of this world. Could there ever be proof of life beyond Earth? Could Mars be the key to unlocking this profound mystery? Its orbit is much farther from the Sun than Earth's, and its temperatures must be far lower. Yet the seasons on Mars change in much the same way as they do on our planet, leading us to wonder whether conditions were once favorable for life. Mars, with its tantalizing hints of past water and its changing seasons, draws us closer in our quest to find life beyond Earth. It is a planet of contradictions, dry and desolate, yet filled with the potential for ancient rivers and seas. Its surface is marked by vast canyons, towering volcanoes, and polar ice caps that grow and recede with the Martian seasons. These features suggest that Mars was once a much more dynamic planet, possibly with a thicker atmosphere and liquid water flowing across its surface. One of the most compelling pieces of evidence for Mars's watery past is the presence of ancient river valleys and delta formations. These geological structures resemble the ones we see on Earth, formed by the erosion and deposition of sediment by flowing water. If Mars once had rivers, lakes, or even oceans, it raises the question of whether life could have existed there in the distant past. Water is the essential ingredient for life as we know it, and where there was once water, there may have been life. The presence of ice at Mars's poles, along with recent discoveries of subsurface ice, further fuels the possibility that the planet may have harbored life in its past. Even today, Mars's polar regions hold vast quantities of frozen water, locked away in ice caps that expand and contract with the changing seasons. Could there still be pockets of liquid water beneath the surface, warmed by geothermal activity or the planet's own internal heat? These questions have led scientists to send missions to Mars to search for signs of life, past or present. Mars's thin atmosphere, composed mostly of carbon dioxide, presents a challenge for life as we know it. Unlike Earth's atmosphere, which provides a protective shield against harmful radiation from the Sun, Mars's atmosphere is too thin to offer much protection. As a result, the planet's surface is bombarded by solar and cosmic radiation, making it an inhospitable environment for most forms of life. However, it is possible that life could have existed in the past, when Mars's atmosphere was thicker and more capable of sustaining liquid water on its surface. Mars's seasons, though similar to Earth's, are far more extreme. The planet's axial tilt is similar to that of Earth, giving it distinct seasons, but because Mars is farther from the Sun, its winters are colder and its summers are milder than those on Earth. The thin atmosphere allows for significant temperature fluctuations, with daytime temperatures near the equator reaching as high as 20 degrees Celsius (68 degrees Fahrenheit), while nighttime temperatures can plummet to -70 degrees Celsius (-94 degrees Fahrenheit). This stark contrast in temperature creates harsh conditions on the Martian surface, making it difficult for life to survive. Despite these challenges, the idea of life on Mars continues to captivate scientists and dreamers alike. Mars, once a symbol of war and destruction, now represents hope, the hope that life is not unique to Earth, that somewhere in the cosmos, there are other worlds where life has taken hold. The search for life on Mars is not just a scientific endeavor, it is a philosophical and existential quest. Finding even the smallest trace of life on Mars would forever change our understanding of the universe and our place within it. In recent years, robotic missions to Mars have uncovered a wealth of information about the planet's geology and climate. Rovers like Curiosity and Perseverance have explored the surface, analyzing rocks, soil, and the atmosphere in search of clues about the planet's past. They have found evidence of ancient riverbeds, minerals that form in the presence of water, and methane in the atmosphere, a gas that, on Earth, is often produced by biological processes. While these findings are not definitive proof of life, they offer tantalizing hints that Mars may have once been a more Earth-like world. The prospect of human exploration of Mars also looms on the horizon. Scientists and engineers are working on the technology needed to send humans to the Red Planet, not just to explore its surface but to live and work there. Mars represents the next frontier for humanity, a place where we might one day establish a colony and take the first steps toward becoming a multiplanetary species. The challenges of such a mission are immense: the long journey, the harsh conditions, the need for sustainable life support systems, but the rewards could be equally great. Exploring Mars could unlock secrets about the origins of life, the history of our solar system, and the potential for human settlement beyond Earth. Mars's two moons, Phobos and Deimos, are also objects of interest. These small, irregularly shaped bodies may be captured asteroids, and their origins are still a matter of debate. Phobos, the larger of the two, orbits so close to Mars that it rises and sets twice each day, racing across the sky. In contrast, Deimos, the smaller moon, orbits farther out and appears more stationary in the sky. The study of these moons could provide further insights into the history of the Martian system and the processes that shaped it. Mars also presents a unique challenge in understanding planetary evolution. Its fate may one day be Earth's. As I observed Mars's barren surface, I could not help but wonder if Earth might experience a similar transformation. What forces led Mars to lose its atmosphere and water? Could something similar happen to Earth if its delicate balance of life-sustaining factors were disturbed? Mars serves as a reminder of the fragility of planetary environments and the importance of protecting the conditions that support life. The search for biomarkers, signs of life or its building blocks, on Mars is one of the most exciting scientific endeavors of our time. Whether in the form of microbial fossils embedded in ancient rocks or the discovery of complex organic molecules, finding evidence of life on Mars would be one of the most profound discoveries in human history. It would suggest that life is not unique to Earth and that the universe is teeming with potential for life in places we have yet to explore. Philosophically, the exploration of Mars forces us to confront questions about the nature of life itself. If life can exist on Mars, what does that say about the universality of life in the cosmos? Could life be a common phenomenon, emerging wherever the right conditions are met? Or is it a rare, fleeting occurrence, dependent on a precise balance of factors that are difficult to replicate? These questions challenge our understanding of our own existence and compel us to continue exploring the cosmos in search of answers. Mars also plays a significant role in the future of space exploration. As humanity looks to the stars, Mars stands as the most likely candidate for the first human colony beyond Earth. Its relatively close proximity, compared to other planets, and its potential resources make it an attractive destination for future explorers. Establishing a presence on Mars would not only expand our knowledge of the planet but also serve as a stepping stone for further exploration of the outer planets and beyond. In many ways, Mars represents our future. It is a world of possibilities, where humanity might one day plant its flag and begin a new chapter in the story of exploration. But it is also a world of caution, reminding us that planetary environments are fragile and that we must take care to preserve the conditions that make Earth a thriving, living world. Mars, the red planet, has moved from being a symbol of war to one of exploration, hope, and curiosity. It challenges us to look beyond our home planet, to imagine a future where humanity lives among the stars, and to seek answers to the fundamental questions about life's existence in the universe. The search for life on Mars is not just about finding microbes in ancient Martian soil, it is about finding our place in the cosmos. Mars beckons us to continue our exploration and, in doing so, to better understand both the universe and ourselves. Mars continues to beckon us, not just as a destination for exploration, but as a mirror reflecting back at us the deeper questions of our existence. As we venture closer to understanding this enigmatic world, Mars prompts us to ask, what is the nature of life? How fragile is the balance that allows it to thrive? And most profoundly, are we alone in the universe? The search for answers on Mars carries implications that extend far beyond the scientific. It touches upon the core of our humanity, our desire to connect with something larger, to understand our place within the vast cosmic tapestry. Though Mars is cold, barren, and seemingly lifeless now, the possibility that it may have once supported life, even in the simplest forms, holds the potential to transform our understanding of life's universality. If life once existed on Mars, however small or short-lived, it would suggest that life could arise wherever the right conditions are met. This discovery would widen the scope of our search for life beyond Earth, encouraging us to look to the moons of Jupiter and Saturn, to distant exoplanets orbiting other stars, and to every corner of the cosmos where liquid water, warmth, and energy might be present. Mars's ancient, dried-up riverbeds, its towering extinct volcanoes like Olympus Mons, and its polar ice caps are all clues to a past that may have been dramatically different from the cold desert we see today. These features suggest that Mars once had a climate capable of supporting liquid water on its surface, a key ingredient for life. The planet's volcanic activity could have provided the heat necessary to maintain subsurface oceans, much like the hidden seas we suspect exist beneath the icy crust of Jupiter's moon Europa. If Mars once had liquid water, and perhaps geothermal heat, then it is entirely possible that microbial life could have emerged in the planet's ancient past. The search for this life, however, is fraught with challenges. Mars's surface today is hostile, exposed to cosmic radiation due to its thin atmosphere, which lacks the protective magnetosphere that shields Earth. Any potential life would have had to retreat underground, where it could be shielded from the deadly radiation that bombards the surface. This is why scientists are so focused on exploring the Martian subsurface, where there may still be reservoirs of water or even microbial life, locked away beneath the layers of rock and ice. The ongoing missions to Mars, such as NASA's Perseverance rover, are not only searching for signs of ancient life but also gathering data to prepare for future human exploration. These robotic explorers are testing technologies that may one day allow humans to live and work on Mars. They are also analyzing the soil, atmosphere, and environmental conditions to better understand how to sustain human life on a planet that is so different from our own. The ultimate goal is to send humans to Mars to explore its surface firsthand, to drill deep beneath the surface, and perhaps one day to build a colony that could serve as humanity's first permanent settlement on another world. The dream of colonizing Mars is no longer the stuff of science fiction. Space agencies and private companies are actively working on plans to send astronauts to the Red Planet within the next few decades. Establishing a human presence on Mars would be a monumental achievement, marking humanity's first steps toward becoming a multiplanetary species. But the challenges are immense. The journey to Mars alone would take months, and once there, astronauts would face extreme conditions, freezing temperatures, low atmospheric pressure, and the ever-present danger of radiation. Despite these obstacles, the lure of Mars is irresistible. For the first time in human history, we have the technology and the will to reach out beyond our home planet and explore a new world. Mars, with its rocky surface, vast deserts, and thin atmosphere, presents a vision of a frontier waiting to be explored. And for those who dream of the future, Mars is more than just a planet. It is a symbol of humanity's capacity for innovation, perseverance, and hope. Mars, in many ways, is also a symbol of survival. Though its surface is barren and lifeless now, the planet's features tell a story of resilience. The massive volcanoes, the deep valleys, and the sprawling plains suggest a planet that has weathered cataclysms and undergone transformations over billions of years. Its surface, though scarred and silent, is a testament to the forces of nature that shaped it. The same forces that eroded its atmosphere and water also carved its majestic landscape. Mars is a reminder that even in the most hostile environments, beauty and wonder can emerge. One of the most intriguing aspects of Mars is its potential to serve as a backup for humanity. As we face growing challenges on Earth, including climate change, overpopulation, and the depletion of natural resources, the idea of colonizing another planet becomes increasingly appealing. Mars, with its vast resources of water ice, its relative proximity to Earth, and its gravity, which is strong enough to allow human habitation yet weak enough to facilitate the launch of spacecraft, is seen as the most viable candidate for such an endeavor. Colonizing Mars would not only be a triumph of human ingenuity but also a safeguard for our species, ensuring that we can continue to thrive even if conditions on Earth become uninhabitable. The process of transforming Mars into a habitable world, or terraforming, is one of the most ambitious concepts in the realm of planetary science. While this idea may still be far in the future, scientists are already considering the steps necessary to make Mars more Earth-like. This could involve releasing greenhouse gases into the Martian atmosphere to warm the planet, melting the polar ice caps to release water, and potentially introducing hardy plants that could produce oxygen. While these ideas are still speculative, they represent the incredible potential for Mars to become a second home for humanity. However, the ethical considerations of terraforming Mars are as vast as the technical challenges. Mars is a world with its own history and possibly even its own biosignatures. If life ever existed there, or if it still does, hiding beneath the surface, what right do we have to alter its environment? Should Mars be preserved as a natural wonder, a pristine example of a planet shaped by the forces of the cosmos? Or should we, as explorers and innovators, seek to make Mars more hospitable for human life? These questions will become more pressing as we move closer to sending humans to Mars and perhaps one day begin to reshape the planet. Mars also stirs in us a deep, almost primal urge to explore and push beyond our limits. Throughout human history, we have been driven by the desire to explore unknown territories, to seek out new frontiers, and to expand our understanding of the world. Mars is the next great frontier. It is the place where our curiosity, our technology, and our sense of adventure converge. By exploring Mars, we are not just seeking scientific knowledge, we are also reaffirming our identity as explorers, as beings who are never content to remain in one place. The exploration of Mars will undoubtedly change us. It will challenge our perceptions of life, our understanding of planetary systems, and our vision of humanity's future. It will force us to confront the reality that Earth is not the center of the universe, nor is it the only place where life might thrive. Mars, with its red deserts and frozen poles, its ancient riverbeds and towering mountains, reminds us that the cosmos is full of possibilities, and that our journey has only just begun. In the end, Mars is more than just a planet, it is a symbol of humanity's unquenchable thirst for knowledge. It stands as a testament to our ability to dream big, to push the boundaries of what is possible, and to strive for a future that is larger than ourselves. As we continue to explore Mars, we are not just seeking to understand its past or unlock its mysteries, we are also exploring the future of humanity, a future where we are no longer confined to one world but are instead citizens of the cosmos. Mars calls us to look beyond the horizon, to dream of what lies ahead, and to embrace the challenges that come with reaching for the stars. As we continue to gaze at Mars, the red planet becomes not only a destination but a profound reminder of our place in the cosmos. Mars pushes us to think beyond our immediate surroundings and envision the future of humanity as an interplanetary species. The quest to explore and colonize Mars forces us to ask deep, existential questions about what it means to be human, the nature of life, and the limits of our potential. Mars, in its stark, barren beauty, evokes a sense of both awe and responsibility. It is a world shaped by forces both familiar and alien, with landscapes that remind us of Earth, yet stripped of the life that makes our home planet so vibrant. The more we learn about Mars, the more we see its potential, not just as a scientific treasure trove, but as a blank canvas on which humanity might one day leave its mark. But Mars also teaches us humility. It reminds us of the forces that can shape and reshape entire planets, and how fragile the balance is that allows life to exist on any world. As we continue to explore Mars, we are forced to consider our role in shaping the future of the solar system. What will our relationship with Mars be? Will we be mere visitors, studying its surface from afar, sending rovers and probes to uncover its secrets? Or will we one day walk its surface, build habitats, and perhaps transform parts of it to make it more hospitable for human life? These questions lead us to confront the nature of our species. Are we caretakers of the cosmos, or are we destined to expand and reshape worlds to fit our needs? The idea of terraforming Mars, once a concept confined to science fiction, is now being seriously considered by scientists and visionaries alike. While the challenges of transforming Mars into a habitable world are immense, the mere possibility raises profound ethical and philosophical questions. What right do we have to alter the environment of another planet? Should Mars be left untouched, a natural monument to the forces of the universe, or should we pursue the dream of making it a second Earth? These are questions that humanity will have to grapple with as we get closer to setting foot on the red planet. The notion of making Mars habitable involves unlocking its hidden resources, particularly water. While Mars may be dry on the surface, there is growing evidence that large quantities of water are trapped beneath its soil and in its polar ice caps. If we can access this water, it could provide the foundation for sustaining human life on Mars. Water is not only essential for drinking, but it can also be used to grow food, generate oxygen, and produce fuel for future missions. The discovery of water on Mars is not just a scientific breakthrough, it is the key to unlocking the planet's potential as a future home for humanity. However, the challenges of living on Mars extend far beyond access to water. The planet's thin atmosphere provides little protection from the sun's radiation, and the surface is bombarded by cosmic rays. Any human settlement on Mars would require extensive shielding or underground habitats to protect the inhabitants from radiation exposure. The extreme cold, with temperatures that can drop below -100 degrees Celsius -148 degrees Fahrenheit at night, presents another hurdle. Developing the technology to create safe, sustainable habitats in such an inhospitable environment will be one of the greatest challenges facing future explorers. Despite these challenges, the dream of colonizing Mars persists, driven by both scientific curiosity and the desire to ensure humanity's survival. Mars represents a new frontier, a place where we can push the boundaries of human knowledge and technology. But it also represents a backup plan, a potential lifeboat for humanity in case Earth becomes uninhabitable due to natural disasters or human-caused environmental degradation. By establishing a colony on Mars, we would be taking a monumental step toward becoming a multiplanetary species, reducing the risk that a single catastrophe on Earth could wipe out human civilization. The desire to colonize Mars also speaks to something deeper within us, the need to explore, to push beyond the boundaries of the known, and to seek out new worlds. This drive has been a part of human nature since our earliest ancestors ventured out of Africa to explore the world beyond their homeland. Mars represents the next step in that journey, the next great challenge that will test our ingenuity, our resilience, and our capacity to adapt to new environments. As we contemplate the future of human exploration on Mars, we must also consider the legacy we leave behind. Will we treat Mars with the same care and respect that we should have shown to Earth? Will we learn from our mistakes and ensure that we do not exploit and degrade the Martian environment as we have done to our own planet? The exploration of Mars offers us a chance to start anew, to build a society that is more in harmony with its surroundings, one that values sustainability and the preservation of natural resources. Mars also forces us to confront the question of life. If we find evidence of past or present life on Mars, it will be one of the most profound discoveries in human history. It would mean that life is not unique to Earth, that it can arise in other places in the universe, perhaps under very different conditions. This discovery would change our understanding of the cosmos and our place in it. We would no longer be the only living beings in the universe, but part of a broader, cosmic web of life. But even if we do not find life on Mars, the search itself is valuable. It reminds us of the importance of asking big questions, of looking beyond ourselves and seeking answers to the mysteries of the universe. The exploration of Mars is about more than just science, it is about the human spirit, about our need to explore, to understand, and to push the boundaries of what is possible. Mars is a world that invites us to dream. It challenges us to imagine what the future could be like if we are willing to take risks, make bold decisions, and work together to achieve something greater than ourselves. It represents the next chapter in humanity's story, one that is still being written, but one that holds the promise of discovery, innovation, and a new understanding of our place in the universe. The future of Mars exploration is bright, filled with possibilities that we are only beginning to grasp. Whether we find evidence of ancient life, establish colonies, or use the planet as a stepping stone to explore even farther reaches of space, Mars will continue to captivate our imaginations and inspire us to reach for the stars. It is a world of mystery and potential, a frontier waiting to be explored, and a reminder that the universe is vast, full of wonders, and open to those who dare to dream. In the end, Mars is not just a destination for exploration, it is a symbol of humanity's enduring quest to understand the cosmos and our place within it. As we continue to explore this fascinating world, we are also exploring ourselves, pushing the limits of what we can achieve, and forging a new path for future generations. Mars calls us to look beyond our own planet, to embrace the unknown, and to strive for a future where the human spirit of discovery knows no bounds. Jupiter, king of planets and its celestial satellites. Jupiter is truly the majestic giant of our solar system, rightfully earning the title of King of Planets. Its size and influence are so colossal that it dwarfs all other planets. Jupiter's grandeur is visible even to the naked eye if you know where to look in the night sky. But its true power is revealed through detailed observation. When I first directed my telescope toward Jupiter, a whole new world opened up before me, not just a gas giant, but an entire system of moons that, like planets, revolve around their mighty host. This discovery was revolutionary, making me question previous ideas about the heavens and the structure of the universe. Jupiter is so massive that its mass exceeds that of all the other planets in the solar system combined. With a diameter of more than 140,000 kilometers, Jupiter could have become a star if it were just a bit larger. Its massive atmosphere, composed mainly of hydrogen and helium, often appears as an uncontrollable chaos. Gigantic cloud belts, colorful storms, and vortices like the Great Red Spot, all of these are evidence of powerful processes occurring within its depths. This colossal storm, raging on Jupiter for over 400 years, is larger than Earth and serves as constant proof that Jupiter is not just a planet, but a dynamic system with incredible energy. But even more astonishing is that Jupiter is not alone. It is surrounded by a swarm of moons, each a unique world with its own features and mysteries. When I first saw 4 bright objects revolving around Jupiter, I was astounded. These moons, Io, Europa, Ganymede, and Callisto, known as the Galilean satellites, became a symbol of a new era in astronomy. The discovery of Jupiter's moons shattered the outdated notion that all celestial bodies must revolve around the Earth. Jupiter was not just a planet but an entire system, much like our own solar system. Io, the first of the Galilean moons, amazes with its volcanic activity. It is the most volcanically active body in the solar system. Massive eruptions, throwing lava kilometers into the sky, occur under the constant gravitational influence of Jupiter. Io seems to live on the edge, experiencing immense tidal forces that tear apart and reshape its surface. It is an example of how a planet or moon can be not just a frozen world but a dynamic and active body, subjected to powerful natural forces. Europa, the second moon, is covered by a smooth layer of ice, beneath which, it is believed, lies a vast ocean of liquid water. This water, warmed by Jupiter's tidal forces, may harbor life. Europa is one of the prime candidates for the presence of extraterrestrial life in our solar system. If this subsurface ocean exists and can sustain life, it could be the greatest discovery in human history. Imagine, life existing on a planet so distant and so different from Earth. It would completely change our understanding of where and how life can arise. Ganymede, the third moon, is the largest moon in the solar system, even bigger than Mercury. It is the only moon known to have its own magnetic field, making it even more unique among celestial bodies. Its surface is marked by deep fractures and icy ridges, indicating a complex and long geological history. Ganymede is a world of contrasts, combining ancient, frozen landscapes with relatively young regions, suggesting possible subsurface activity. Callisto, the fourth Galilean moon, is shrouded in an air of ancient mystery. This icy world is almost entirely covered in craters and may be one of the oldest objects in the solar system. It bears the scars of collisions with meteors and other cosmic bodies that occurred billions of years ago. Its surface is a window into the past, preserving the history of planetary formation and evolution. Callisto, seemingly frozen in its development, remains one of the most enigmatic moons, holding the secrets of the distant past of the solar system. But Jupiter is not limited to these 4 moons. It is orbited by dozens of other bodies, ranging from small rocky moons to large icy satellites. In total, Jupiter has over 79 known moons, each with its own unique features. Some of these moons are merely asteroids captured by Jupiter's powerful gravity, but even they are of interest for study. Jupiter, like a mighty ruler, holds these moons with its gravity, creating a miniature solar system within our own. Yet Jupiter's role extends beyond its moons. Jupiter acts as a kind of shield for the inner part of the solar system, including Earth. Its powerful gravity deflects and attracts many comets and asteroids that could pose a threat to our planet. Jupiter has saved Earth from catastrophic collisions with cosmic objects on multiple occasions, taking the impact upon itself. Its gravitational force, like a barrier, protects the inner planets, maintaining stability within the solar system. But why is Jupiter so important to us? Beyond its role as a protector, Jupiter is a kind of laboratory where scientists can study the processes occurring within the interiors of planets and stars. Its atmosphere is composed mainly of hydrogen and helium, the same elements that make up the Sun, allowing researchers to study it as a failed star. If Jupiter were a bit larger, nuclear fusion could have started in its core, turning it into a second star in our system. This makes Jupiter a unique object for studying the processes of star formation. Jupiter's magnetosphere is also one of the most powerful in the entire solar system. Its magnetic field is so large that if it glowed like Earth's atmosphere, it would be visible from Earth as an object twice the size of the Moon. This magnetosphere protects Jupiter and its moons from cosmic radiation, while at the same time creating enormous radiation belts that pose a serious threat to spacecraft studying the planet. Jupiter is not just a planet, it is an entire ecosystem, including moons, rings, powerful magnetic fields, and swirling storms. Its majesty is awe-inspiring, and it remains one of the most captivating objects for study in the solar system. Jupiter is a symbol of cosmic power, and its influence extends far beyond its gravitational field. It reminds us that the solar system is not just a collection of planets but a complex and dynamic system where each body plays its part. The study of Jupiter and its moons continues to open new horizons of knowledge. I believe that in the future, we will delve even deeper into the mysteries of this planet and its satellites, and these discoveries will allow us to better understand not only our solar system but also the processes occurring in other systems of stars and planets. Jupiter is not just the king of planets, it is a key to understanding the cosmos and our role within it. As we continue our journey of exploration, Jupiter remains at the forefront of our quest to unlock the secrets of the cosmos. This mighty gas giant, with its turbulent atmosphere and intricate system of moons, provides us with a glimpse into the dynamic processes that shape not only our solar system but potentially countless other star systems throughout the universe. The study of Jupiter is not only a window into the nature of giant planets, but also a means of understanding the delicate balance of forces that govern planetary systems and the potential for life beyond Earth. Jupiter's colossal atmosphere, filled with storms and swirling clouds, offers a natural laboratory for understanding the physics of gas giants. The massive storms that rage across its surface, like the Great Red Spot, are more than just visually stunning, they hold the key to understanding atmospheric dynamics on a grand scale. These storms, which can last for centuries or even millennia, are fueled by the complex interplay between the planet's internal heat and its rapid rotation. By studying these phenomena, scientists hope to gain insights into the behavior of atmospheres on other gas giants, both within our solar system and beyond. But the mysteries of Jupiter extend far beyond its atmosphere. Its vast system of moons, each with its own unique features and histories, provides us with an unparalleled opportunity to study the diversity of planetary bodies. These moons are more than just satellites, they are worlds in their own right, with geological activity, atmospheres, and even the potential for life. Europa, with its subsurface ocean, holds the promise of one of the most exciting discoveries in the history of space exploration, the possibility of life beyond Earth. The icy shell that covers Europa may conceal an entire ecosystem, warmed by the tidal forces exerted by Jupiter's massive gravitational pull. If life exists beneath the surface of Europa, it could forever change our understanding of biology and the conditions necessary for life to thrive. Ganymede, the largest moon in the solar system, stands as a reminder that moons, like planets, can be diverse and complex. With its own magnetic field, Ganymede is a rare celestial body, offering clues about the magnetic and geological processes that operate on planetary scales. Its surface, marked by fractures and ice ridges, suggests a history of tectonic activity, providing scientists with a fascinating case study in planetary evolution. Similarly, Callisto, with its heavily cratered surface, serves as a time capsule, preserving the history of the early solar system and the bombardments that shaped the planets and moons. As we study these moons, we are not just learning about Jupiter's domain, but about the broader processes that govern planetary formation and evolution. Each moon tells a different story, and together, they provide a comprehensive picture of how complex and varied the solar system can be. The insights we gain from studying these moons could help us understand the formation of planets around other stars, particularly those with gas giants like Jupiter. By comparing Jupiter and its moons with exoplanetary systems, we can begin to piece together the universal principles that govern planetary systems. Jupiter's influence also extends beyond its own moons. Its powerful magnetic field, which traps charged particles and creates intense radiation belts, has a far-reaching impact on the space environment around it. These radiation belts are so strong that they pose a significant challenge to spacecraft trying to explore the planet and its moons. Future missions to Jupiter must contend with this harsh environment, but studying Jupiter's magnetosphere is critical for understanding the magnetic fields of other planets, both in our solar system and around distant stars. Moreover, Jupiter plays a vital role in protecting the inner solar system, including Earth. Its immense gravitational force acts as a cosmic shield, deflecting many comets and asteroids that might otherwise threaten the inner planets. This gravitational barrier helps maintain the stability of the solar system, reducing the likelihood of catastrophic impacts that could disrupt life on Earth. Without Jupiter's protective influence, the inner planets would be far more vulnerable to the hazards of space. In the future, we can expect that our exploration of Jupiter and its moons will deepen, driven by new missions and technologies. Robotic missions, like NASA's upcoming Europa Clipper, aim to explore the icy moon Europa in greater detail, seeking to confirm the existence of its subsurface ocean and assess its potential for supporting life. Other future missions may target Ganymede or Io, further investigating the geological activity that makes these moons so fascinating. Each new mission will bring us closer to understanding the complex interactions between Jupiter, its moons, and the larger solar system. Humanity's journey to Jupiter may one day extend beyond robotic exploration. As we look to the future of space exploration, the idea of sending humans to explore the moons of Jupiter becomes an increasingly exciting possibility. Establishing outposts on these distant worlds, particularly on Europa, could allow scientists to conduct in-depth research, drilling through the ice to explore the hidden ocean beneath. The technological challenges are immense, but the rewards, both scientific and philosophical, could be unparalleled. The exploration of Jupiter also offers a powerful reminder of our place in the universe. As we study this giant planet and its moons, we are confronted with the vastness of the cosmos and the intricate complexity of the systems that make up our solar system. Jupiter, with its immense size and power, serves as a reminder that the universe is far grander and more mysterious than we can easily comprehend. It challenges us to look beyond the boundaries of our own world and to strive for a deeper understanding of the forces that shape the cosmos. Jupiter's importance extends beyond the scientific. It has long captured the imagination of humanity, inspiring myths, stories, and artwork throughout the ages. In ancient times, Jupiter was seen as a symbol of power and authority, a reflection of its dominance in the night sky. Today, as we explore Jupiter with modern technology, it continues to inspire awe and wonder. It reminds us that, despite our technological advancements, there is still so much we do not know about the universe, and that the pursuit of knowledge is a journey without end. As we continue to explore Jupiter, we are not just seeking answers to scientific questions. We are engaging in a broader exploration of the nature of the universe and our place within it. Jupiter, as the largest and most powerful planet in the solar system, stands as a beacon of cosmic power, drawing us ever closer to the mysteries of the cosmos. Its moons, with their potential for life and geological activity, offer a tantalizing glimpse of the diversity of worlds that exist within our own solar system and beyond. Jupiter is not just the king of planets, it is a symbol of humanity's unquenchable thirst for exploration and discovery. It represents the next frontier in our quest to understand the cosmos, and its study will continue to shape our understanding of the universe for generations to come. As we gaze upon Jupiter and its swirling storms, its vast moons, and its powerful magnetic fields, we are reminded of the immense scale of the universe and the endless possibilities that lie ahead. In the end, Jupiter is more than just a planet, it is a key to unlocking the mysteries of the cosmos. Through its study, we learn not only about the forces that shape our solar system but also about the larger universe in which we are all connected. Jupiter invites us to look beyond our world, to push the boundaries of human knowledge, and to embrace the spirit of discovery that has driven humanity throughout history. As we continue to explore this majestic planet, we are reminded that the universe is vast, full of wonders, and open to those who dare to seek the truth. Conclusion: a look to the future. When I began my observations, I could not have imagined just how vast and astounding the mysteries hidden in the endless expanse of the universe would turn out to be. Every new glance at the heavens, each new star or planet observed through the telescope, only deepened my understanding that our place in the universe is not what we once thought. My study of the solar system led me to conclude that it is but a small part of a far more grand and unexplored universe, filled with mysteries that we are yet to uncover. Knowledge is an eternal pursuit of truth, and throughout history, humanity has always reached for the stars in search of answers to questions about our origins and the meaning of our existence. Now that our instruments are precise enough to peer beyond our world, we realize that the heavens are an endless ocean of mysteries that surpass our wildest expectations. This knowledge not only brings us closer to understanding the structure of the universe but also opens up new horizons. Yet, with every discovery comes new questions, and it seems the more we learn, the more there is left to discover. The solar system, which I observed with my instruments, turned out to be more than just a collection of planets. It is a dynamic system, full of life and motion. Each planet, its moons, and the processes surrounding them form a complex picture of interactions, gravity, and energy. But beyond our world lies an infinite number of other systems, star systems, galaxies, clusters, and each of them holds its own secrets. We stand at the threshold of a great journey into the unknown corners of the universe. The future of humanity depends on how we use the knowledge that unfolds before us. With each new generation of astronomers and explorers come new instruments, new theories, and methods that allow us to peer even farther and deeper into space. Perhaps in the future, scientists will be able to look beyond the observable universe, uncovering new laws of physics and understanding time and space in ways we cannot yet fathom. I dream of a time when humanity will explore not just the nearest planets, but the stars of other systems, and perhaps one day, we will meet other civilizations as ancient and wise as our own. Knowledge is an infinite process, and each step on this path brings us closer to solving the great mysteries of the universe. We live on a remarkable planet, blessed with unique conditions for life. But we cannot remain here forever. Space is our destiny, our future, and I am certain that one day humanity will become a spacefaring civilization, exploring distant stars and planets. We will journey to new worlds, build cities on other planets, extract resources from asteroids, and explore what now seems impossible. Yet this path will be full of challenges and obstacles. To become a spacefaring civilization, we will need to solve countless technical, ethical, and philosophical questions. How will we protect our astronauts from radiation? How will we traverse the immense distances that separate us from the nearest stars? How will we preserve ecosystems as we begin to settle new worlds? These are the questions that future scientists, engineers, and philosophers will face, but I believe humanity will find the answers. Each new discovery, each new piece of knowledge we gain about the cosmos, makes us stronger and wiser. Our solar system is just the first chapter in the great book of the universe, and I am confident that many exciting discoveries await us in the future. We will learn more about the nature of dark matter, understand the essence of black holes, and study the nature of time and space. These discoveries will not only reshape our understanding of the universe but also transform us as individuals. We will realize that our planet is not the center of the universe, but merely one of countless worlds scattered throughout the vastness of space. Future scientists, continuing my work, will uncover new worlds, new forms of life, and new laws of nature. But most importantly, they will discover new ways to interact with the world and the universe. We will understand that knowledge is not just the accumulation of facts, but a deep comprehension of our place in this boundless cosmic ocean. And each new generation of scientists will continue this great work, making new discoveries and unraveling new mysteries. However, along with these discoveries will come the realization of our responsibility. A responsibility for our planet, for our solar system, and for the universe as a whole. We will understand that Earth is our home, but we cannot stay in it forever. We must protect our planet so that future generations can enjoy its beauty and resources. But we must also seek paths to the stars, to open up new horizons and possibilities for ourselves. I hope that the future of humanity will be not only about new scientific discoveries but also about a deep awareness of our responsibility to the cosmos. We are not alone in the universe, and we must treat it with respect and caution. We must cherish what we have, but also strive for more. Our future lies in the stars, and I believe that one day, we will be able to comprehend its grand essence. Knowledge is an endless journey, and we are only at the beginning of this path. Each new discovery, each new piece of knowledge opens up new horizons before us. And even if we never manage to solve all the mysteries of the universe, the very process of seeking and striving for knowledge makes us better, wiser, and stronger. We are children of the stars, and our future is bound to them. And I believe that one day we will be able to answer all the questions the universe presents to us. As humanity continues to push the boundaries of knowledge, we will face the same questions that have driven our curiosity since the dawn of time. The pursuit of understanding will take us to unimaginable heights, both in the physical exploration of space and in the metaphysical contemplation of our place in the cosmos. Every step forward, every new discovery, will bring us closer to answering the fundamental questions about existence, purpose, and the mechanics of the universe itself. The process of seeking answers has always been marked by perseverance and the willingness to confront the unknown. In my time, the invention of the telescope revolutionized our view of the cosmos, revealing that the universe is far more complex and dynamic than we had ever imagined. Since then, every generation has built upon the knowledge of those who came before, each new discovery revealing yet another layer of complexity. The future promises even greater revelations, as our technological advancements will allow us to look deeper into the universe and back in time to the very beginning of creation. But even as we peer into the farthest reaches of space, we must not forget that our understanding of the cosmos begins here, on Earth. Our planet is a microcosm of the universe itself, governed by the same physical laws that shape the stars, planets, and galaxies. The movements of celestial bodies reflect the principles that operate on both the grandest and smallest scales. As we learn more about the forces that govern Earth, we deepen our understanding of the universe as a whole. In this sense, Earth is not just our home, it is our starting point in the grand quest for knowledge. From the moment we first observed the patterns of the stars in the night sky, humanity has been driven to understand the forces that shape the cosmos. Our solar system is but a small, intimate corner of the universe, yet it holds within it the answers to questions that span galaxies and epochs. Each planet, moon, and star is a piece of the grand puzzle, waiting to be understood. The exploration of our neighboring planets, like Mars and Jupiter, will undoubtedly reveal new insights into the forces that shape planetary systems. These discoveries will not only deepen our understanding of the solar system but also help us to develop the tools and technologies necessary for exploring the farthest reaches of space. As we solve the mysteries of our own system, we will become better equipped to confront the mysteries of distant worlds and galaxies. The greatest challenge in this journey will be time itself. The distances between stars are vast, and even traveling to the nearest one would take generations with our current technology. But I believe that humanity will find ways to overcome these challenges. New forms of propulsion, new methods of communication, and perhaps even new understandings of physics will one day allow us to bridge the distances between the stars. When that day comes, humanity will embark on its greatest adventure yet, the exploration of other star systems, each with its own unique planets, environments, and possibly life forms. The discovery of life beyond Earth would be the most profound moment in the history of human civilization. For millennia, we have wondered whether we are alone in the universe. If life can exist on other planets, even in forms that are entirely different from those we know, it would confirm that life is not an anomaly but a fundamental part of the fabric of the cosmos. This realization would reshape our understanding of biology, evolution, and our place in the universe. Yet, as we search for life on other planets, we must also come to terms with the possibility that life might be incredibly rare. Earth may be one of the few places where the delicate balance of conditions necessary for life has been achieved. If that is the case, then our responsibility to protect and preserve life on this planet becomes even more urgent. The Earth, with its rich biodiversity and unique ecosystems, could be the most precious place in the universe. As we prepare to expand our presence in space, we must develop an ethic of care for the environments we encounter. Whether we are exploring Mars, the moons of Jupiter, or distant exoplanets, we must be mindful of the impact our actions will have on these worlds. Just as we have learned to care for our own planet, we must extend that care to the rest of the universe. Our exploration should be guided not only by the desire for knowledge but also by the responsibility to protect the environments we explore. The universe is vast, and our journey through it will be long. But with each step, we will learn more about the forces that shape the stars, the planets, and ourselves. Every new discovery will add to the tapestry of knowledge, weaving together a picture of the cosmos that is more complete and more profound than anything we can currently imagine. The mysteries of the universe will not be solved in a single lifetime, but the pursuit of those mysteries will continue to drive humanity forward, generation after generation. In the distant future, I imagine a time when humanity will have spread out among the stars, establishing colonies on distant planets and forging connections with other intelligent civilizations. We will have moved beyond our current understanding of space and time, unlocking new dimensions of existence that we cannot yet comprehend. As we explore these new frontiers, we will be guided by the same curiosity and thirst for knowledge that has driven us since the beginning of time. But even in this distant future, we will continue to look back at the Earth as our home, the place where our journey began. The lessons we learn from exploring the universe will help us to better appreciate the unique beauty and fragility of our planet. We will come to understand that, despite the vastness of the universe, Earth holds a special place in the grand scheme of things. It is the cradle of life, the place where consciousness first emerged, and the starting point for our journey into the stars. As we look to the future, we must remember that the journey of exploration is not just about reaching distant worlds, it is also about understanding ourselves and our place in the universe. The stars may be our destination, but the lessons we learn along the way will shape the course of human history. Each new discovery will change us, deepening our understanding of what it means to be human and expanding our vision of what is possible. The future of humanity lies in the stars, and I believe that one day, we will reach them. But in reaching for the stars, we must never forget the Earth, our home, and the responsibility we have to care for it. The universe is vast, and there is so much to learn. Yet, as we explore the cosmos, we must also explore the depths of our own humanity, understanding that the quest for knowledge is ultimately a quest to understand ourselves. In the end, the universe will always hold mysteries beyond our reach. But the pursuit of those mysteries, the desire to know and to understand, is what makes us human. We are, and always will be, explorers, children of the stars, destined to reach for the unknown and to expand the boundaries of knowledge. And in doing so, we will discover not only the secrets of the universe but also the true potential of our own existence.